great thing about Pigeonhole principle is that you can use it to solve some pretty messy real-world problems without doing a whole lot of work. For example, there's a lot of trees on planet Earth, right? Millions and billions of them. And yet, without leaving the building, we can tell that at any given moment in time, there are going to be 2 leafy trees on this planet that have the exact same number of leaves. Now, these kinds of problems bring to mind that we need other kinds of skills to solve them. Some skills that we are going to need are the ability to collect good data. Are we able to Google for things? And are we able to pick sites that actually have some merit to them? Can we make smart assumptions that make our solution both possible to do, but still convincing? We're not about to go outside and start sampling tree counts or counting all of the trees. We're not going to go outside and pick all of the leaves off of an oak tree so that we can get an accurate leaf count. We have to do some thinking about how to estimate things in an intelligent way. And finally, when we're making these decisions, we need to balance the need for speed with the need for accuracy, right? We don't want this solution to take all day. We don't have all day, but we still need it to be pretty good. And so that takes some judgment. Now, what makes this problem hard to do? First of all, it's practically impossible to count the number of trees, even if we have satellite imagery. Secondly, it's too difficult to count the number of leaves on any decently sized tree. And think about it, those numbers are changing all the time. What if you went outside and started counting the leaves on an oak tree, and then a breeze blew up and 50 leaves blew off? What are you supposed to do then? Finally, which trees should we count? So technically, needles count as leaves. So are we counting conifers? Or when they say leafy trees, are we only counting the deciduous trees? So this problem isn't precisely worded, so we have to make some decisions just to make the problem possible to solve. So here are my decisions. I'm only going to count the deciduous trees, and I'm going to ignore all of the pine and spruce trees. I'm going to Google a number for leaves on a really big tree. And because what I need for Pigeonhole principle is I need the number of leaves on the leafiest possible tree, I'm going to take whatever estimate I find and I'm going to triple it. I'm going to say, fine, there's probably some tree out there that's 3 times as big, so we'll just triple it. That's my decision. And finally, I'm going to Google around and try to find an estimate for the number of trees on Earth rather than try to use Google Earth or whatever to calculate an estimate for myself. So the first thing I find when I'm Googling is this nice website where someone has done a pretty convincing calculation estimating the number of leaves on a large tree. And they claim that a large oak tree can have as many as 2 million leaves. So now oak trees aren't necessarily the leafiest possible trees. There might be trees with like many more teeny tiny leaves. So like I said, I'm going to triple that and I'm going to use 6 million as my max. Then I keep Googling and I find this pretty recent article from BBC where, based on satellite imagery, some scientists at Yale think that maybe there are over 3 trillion trees on Earth, and maybe 2/3 of those are deciduous. So, a really leafy oak tree has 2 million leaves according to my source. So I'm going to guess that there's some crazy leafy tree out there with 6 million leaves. Secondly, the internet said there were 3 trillion trees on Earth, maybe 2/3 of those are deciduous, so that leaves us with a guess of 2 trillion leafy trees. Okay, now it's time for the Pigeonhole principle. If every tree on Earth had its own unique leaf count, meaning there's a single tree out there with 1 lonely little leaf, there's another tree with 2 leaves, and now no other tree on the planet is allowed to have 1 or 2 leaves. There's a single tree with 3, a single tree with 4, a single tree with 5, and so on and so forth. So you can use up 6 million trees that way, right? But that actually leaves almost 2 trillion trees left. 1,999,994,000,000. Way more trees than there are leaves possible. So if I were writing this up in my homework, what information would I include? I would definitely include sources for any numbers I had to Google, just copy paste links, right? Very easy to do. If I had to make assumptions in order to make the problem possible or clarify it, I should write those down. And I should also write down my reasons for making them. If I had to do any computations, like say the 2/3 of trees are deciduous, that kind of computation, I would write those down as well. And finally, I would write down my conclusion. I would say all of this work supports my argument that there are way more trees on Earth than there are leaves on the leafiest possible tree. Therefore, 2 trees have to share a leaf count.